Now we're in our final section of systems of equations, which deals with our last method of solving them, which is the elimination method, sometimes also called the addition method. So if you see that phrase solved by the addition method, it really means the elimination method. It's just they're interchangeable terms for the same process. All right, so we recall that a system of equations for us was two linear equations, each having two variables. So we've solved them by graphing and by substitution so far. So now we're going to move on to the elimination method. And an important concept in solving systems by elimination is the concept of least common multiple. Okay, so that's one thing. And the other thing is that generally speaking, when you're going to solve these systems by elimination, you want to get them into that ax plus by equals c form. So basically you're getting all the variables on one side and then the constant by itself on the other side. So that's sometimes called the general form of a line, right? We've looked at slope-intercept form of the line. The ax plus by equals c form is sometimes called the general form of a line. All right, so here's what you're going to do to solve a system by elimination. So what's going to have to happen is you're going to have to identify a variable that you want to eliminate. And then what you're going to do is you're going to multiply either one or both equations by a number so that the coefficient of one of the variables in the first equation is the opposite of the coefficient of the same variable in the second equation. So you're going to try to shoot for things like 4x and negative 4x, negative 2y and positive 2y, things like that. Because the idea behind that is once they're opposite coefficients, when you add the two equations, they're going to cancel out. And then you're going to be able to eliminate that variable, and then you'll leave a simple equation that only has one variable left, okay, because you've eliminated the other one. And then you'll just solve that equation to find the first variable, and then you'll substitute that value into either equation, and you'll find the other variable. And of course, you should do checks at the end. All right, so the first couple of these, I take you through them in steps. So there's a lot of scaffolding involved here, okay? So here's an example, and in this handout, I actually have the little curly brace to tie them together, so that's good. So what you do here is you look at these two equations, 2x minus 3y equals 7 and negative 6x plus 2y equals 21, and you look at the x's. I mean, I could look at the y's, but here they're kind of forcing my hand to look at the x's. So I have a 2x and a negative 6x. So right now the coefficients of x are 2 and negative 6. So what I'm going to do now is I'm going to try to find the least common multiple of 2 and 6, right? The sign you don't have to worry about yet. So think of that as 2 and 6. So what's the least common multiple of 2 and 6? Well, the smallest number in both the times tables, right, the 2 times tables and the 6 times tables is actually 6. So what you're going to want to do is you're going to want to turn this 2x into 6x, and that negative 6x can stay the way it is, because then once this is 6x and that's negative 6x, when you add them, they'll cancel out. So in this case, the only one you need to multiply is you need to multiply the top equation by, well, how do you turn 2 into 6 by multiplication? You multiply it by 3. Because then once you do that, the coefficients will be 6 and negative 6. And then what will happen with 6x and negative 6x is they'll cancel out. All right, so the idea is, how did we get from this first step to this second step? Well, we just took the first equation and we multiplied each part of it, right, all three pieces, by 3. So 3 times 2x gave me 6x. 3 times negative 3y gave me negative 9y. And 3 times 7 gave me 21. So here's my second step. And now what I can do is, now I can just add these two equations up. And when I add these two equations up, 6x and negative 6x cancel each other out. Negative 9y plus 2y gives me negative 7y, and 21 plus 21 equals 42. So you're just adding, the like components, right? So I added the x's, they canceled. I added the y's, they gave me negative 7y. I added the 21 and 21, and I got 42. So now I can just easily solve this equation by just dividing by negative 7. So I divide by negative 7, and I get y equals negative 6. And then I would go back to one of my original equations, and I would substitute this negative 6 in for y. So I write 2x minus 3 times negative 6 equals 7. And then I'll just solve this, right? Because the negative 3 times negative 6 is 18. So this is 2x plus 18 equals 7. And then I'll subtract 18. So I'll have 2x equals negative 11, and then I'll divide by 2. So x equals negative 11 over 2. I mean, you could write negative 5.5, but negative 11 over 2 will suffice, especially because you generally want to avoid decimals, because if they're repeating, you don't want to write them. So my solution in this case would be an ordered pair. If I want to write it as an ordered pair, negative 11 over 2, negative 6. And then you can do a quick check on that to make sure that it's going to work. And as I had mentioned, you generally want to do checks on the calculator because you don't want to make any calculation mistakes. So if you just rewrite the equation, right, retype the equation as is, inserting the values for the two variables, right, that's the top one, 2 times negative 11 over 2 minus 3 times negative 6, and that should equal 7, check. And then I do the other one, so negative 6 times negative 11 over 2 plus 2 times negative 6, and that should equal 21. So it checks in both equations. So moving on to our second example here, negative 3x plus 4y equals 6 and 5x plus 3y equals negative 10. Now in this case, one might make the argument, and it would probably be a good argument, that it's actually easier to eliminate the x variable in this instance, but it seems like I'm forcing your hand here to discuss the y, so I guess it looks like we're going to be eliminating y here. So if we look at these two equations, we can see that the coefficients of y are 4 and 3. So what we want to do is we want to find the least common multiple of 4 and 3. Well, in this case, it's just that old trick that you used to use with fractions. Just multiply them and you get the least common multiple in this case. So 4 times 3, so the least common multiple is going to be 12. So what you're going to want to do is you're going to want to make the coefficients become 12 and negative 12. Okay, because if they're both 12, then they're not going to cancel. So we want them to be a positive 12 and a negative 12. So what we're going to do is we're going to multiply that top equation. We want to turn 4y into 12y, so we're going to multiply it by 3. And on the bottom equation, we're going to turn 3y into negative 12y, so we're going to multiply that bottom equation. So 3 times what will give me negative 12? Negative 4. So I'm going to multiply the bottom equation by negative 4, because then I'll end up having a 12 and a negative 12 as my y coefficients. So then they can cancel out. So you can see how we get to our second step here just by multiplying each piece. Okay, so negative 9x plus 12y equals 18, and negative 20x minus 12y equals 40. And the key thing, this is the thing that a lot of times people leave out, you also have to multiply the right side. Right? A lot of times people will write negative 9x plus 12y equals 6. Negative 20x minus 12y equals negative 10. You have to distribute that number you're multiplying to all three pieces, right? Both sides. So 2 pieces on the left side, 1 piece on the right side. Okay? You have to multiply every single piece of it. So now when you have it like this, the idea was you wanted the y's to cancel, and when you add 12y and negative 12y, of course they cancel. Negative 9x and negative 20x give you negative 29x, and 18 and 40 give you 58. So when I divide this by negative 29, 58 divided by negative 29 is just negative 2. Okay? And then I will substitute this into either equation, but I'll just use the top one to get my other variable. So this is 6 plus 4y equals 6. And then when I subtract 6, this is another place where sometimes people go wrong, and they accidentally think that there's no solution because they do something like this. They say, oh, 6 and negative 6 cancel, so I just have 4y. No, 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 no. This is an equation, so you always have to have two sides. Now, sometimes one or both of the sides, it's 0, but that's fine. 6 minus 6, you still have to write a 0 over there. So in this case, 4y equals 0, which you can still solve, divide by 4, and 0 divided by 4 is still 0. Okay, so in this case, my solution is negative 2, 0. And then again, I can do a check in this by substituting. So negative 9 times negative 2. And this one is easier to check because one of the variables is 0. So you don't even honestly need a calculator for this one. It would be easy to check, by hand. But negative 9 times negative 2 plus 12 times 0 equals 18. So that works. And then negative 20 times negative 2 minus 12 times 0, and that equals 40. So it checks in both equations. So these last two you should really practice on your own before I go through them, and then resume this video after you try them on your own. This next one, 6x minus 8y equals 5 and negative 4x plus 2y equals negative 10. So in this case, there's no guidance, so you can pick either variable. Okay, now personally, I would choose to eliminate y here rather than x because I'd only have to multiply one of the equations. If I choose to eliminate x, I'm going to have to multiply both equations, which is fine. It's one less thing to worry about if I eliminate y. So what I'll do is I'll look at the y's and I'll say, all right, my coefficients are negative 8 and 2. So what's the least common multiple of 2 and 8? So the LCM of 2 and 8 is 8. So what that means is that negative 8y can stay as it is. So I don't even need to multiply that top equation by anything. So I just want to turn that 2y into a positive 8y, so then it'll cancel out. So 2 times what will give me 8? Well, I'll just multiply the bottom equation by 4, and I can leave the top equation untouched. So I'll just rewrite the top equation. And then when I multiply the bottom equation by 4, again, remember all three pieces, you get this. And then when you add them up, you'll get negative 10x equals negative 35, and you'll just divide by negative 10. So you're going to get x equals, that's going to be 7 over 2. You could write 3.5, but 7 over 2 also would work. And now you'll take this and replace it for x in either equation. I'll use the top one again. So 6 times 7 over 2, this is going to be 21. And then I'll subtract 21, and then I'll divide by negative 8. So y is going to be 2. So in this case, my solution is 7 over 2, 2. Right? And again, I'll take solutions like this, just separated like this, x equals 7 over 2, y equals 2, as long as it's clear that they're both solutions. Or if you wish, you can write it as a ordered pair. So this final example throws us the obligatory curveball. So let's say we have 2x minus 3y equals negative 8 and negative 6x plus 9y equals 12. I've already highlighted the 2 and the negative 6 coefficients, indicating that that's the variable I want to look to eliminate. So we have 2 and 6 as our coefficients, well 2 and negative 6. They're already opposites. So the LCM of 2 and 6 would be 6. So all I really need to do here is multiply this top equation by 3, because then I'll have a 6x and a negative 6x, which will cancel. So if I multiply the top equation by 3, I get 6x minus 9y equals negative 24. And the bottom equation can say negative 6x plus 9y equals 12. Didn't need to multiply that one. And now when I add these up, okay, my x's cancel, which is what I wanted, but also my y's cancel. So on this left side, everything canceled out. That means I'm really left with 0 on my left side. And on my right side, I have negative 24 plus 12, which is negative 12. And remember, we had talked about this. This is a false statement because obviously 0 is not equal to negative 12. And what that meant is that there is no solution to this system of equations. Now, graphically, what does it mean? It means that they were parallel lines. Okay, so if I went to graph these two equations, they would end up being parallel lines. And you can see that actually if you try to put them in the y equal mx plus b form, that's probably the easier way to do it, to check it graphically to make sure that they're parallel lines. Take that top equation, right? 2x minus 3y equals negative 8. Solve it for y, right? So I would subtract 2x and then I divide everything by negative 3. So I end up with y equals positive 2/3 x minus 8/3. That's my top equation. And my bottom equation, if I solve it for y, add 6x. So 9y equals 6x plus 12. And then divide everything by 9. And this is going to be y equals 6/9 is really 2/3 x. And 12/9 is 4/3. So then when you look at these two lines in slope-intercept form, you can see that they're in fact parallel lines because they have the same slope, but they have different y-intercepts. So they are in fact parallel lines, which explains why there was no solution.